Okay, number 14 and 15, you're solving each of these systems of equations, and you have to use the substitution method to do so. When you have solved a system of equation, you should get a point. So we represent points as an ordered pair. So you should have an x-coordinate and a y-coordinate, which you put in parentheses to show it's a point. So each one of these equations represents a line. Since you're given two lines at a time, you're being asked what point or points do they have in common. Well, you should have learned in Algebra 1 that there's three things that could happen when you have two lines. They could be parallel lines, which means they don't cross or have any points in common at all, so you would have no solution if that were the case. You could graph both lines and see, oh, they're actually the same exact line, meaning one's on top of the other, which means they share all points in common. That's where we have infinite solutions. Or you could have two lines that intersect each other, and that would be a solution of 1 point, which is what we're going to have on these. We're trying to find that 1 point that they have in common. Okay, so since that's a point, remember you're going to represent it as an ordered pair. So there's several ways you can solve a system of equations, and you should have learned those ways in Algebra 1 last year. You can use your graphing calculator to find where they intersect. You can use elimination as your process of finding the point that they have in common. But for geometry, we mainly use substitution method on a lot of our concepts, so that's what we wanted you to practice on that. Now, the substitution property just says if you know two things are equal, let's say A equals B, that means everywhere I see an A, I can replace it with a B because they're equivalent to each other. So if I know X equals 2, everywhere I see an X, I can replace it with a 2 because those are equivalent to each other. That's all substitution means. So when you have two lines and you're using the substitution property, you want to either find out what y equals or what x equals, meaning you want one of your equations to be isolated for one of those variables. Well, on the first one, you can look at both equations, but this one's already got one of the variables by itself. Y is equal to 5x plus 19. So using the substitution property, that means wherever I see a y, I can replace it with the 5x plus 19. So I'm going to go to my second equation, and I'm going to replace this y with 5x plus 19. Now, using parentheses here is very important, and we'll see why. So I'm going to write this equation, but instead of writing the y, I'm going to put a set of parentheses. So you see I just wrote the second equation, but instead of writing a y, I put a set of parentheses. So inside that parentheses, I'm going to put what I'm replacing y with. Y is equal to 5x plus 19. So I'm going to put the 5x plus 19 here in the parentheses. The reason why the parentheses is important is because this negative 8 is being multiplied by that entire binomial, meaning I'm going to have to remember to distribute that negative 8. So now I have an equation that only has an x in it. Before it had an x and a y, so I couldn't find out what either one of those were because I had two variables. But now that I have an equation that only has an x, I can solve and find what x equals. So be careful with your sign here. This 8 is negative because of that subtraction sign in front of it. So this 3x is negative. Negative 8 times 5 is negative 40. So I have negative 40x. And then negative 8 times positive 19. Negative 8 times 19 is negative 152. So minus 152. So I've gotten rid of my parentheses by distributing that negative 8 times both terms. Now on this side of the equation I have like terms here. Both of these have an x. So if I have negative 3x's and another negative 40x's, I have a total of negative 43x's. And you can put that in your calculator if you need to. Negative 3 minus 40 is negative 43. And then don't forget this minus 152 equals 20. Now this is just a two-step equation. To get x by itself, I have to undo multiplication and subtraction. So we undo subtraction first by adding 152 to both sides. We get the negative 43x is equal to 172. And then remember, this is multiplication, so you undo it using division. Divide both sides by negative 43. So 172 divided by negative 43 is negative 4. Now, I'm not finished. Remember, my answer should be a point, an ordered pair. I know the x now, so I know part of the point, but I don't know what my y value is yet. But to find the y value, I can go up here to either one of these equations and replace the x with negative 4. The one that's easiest is this one that's already solved for y. Since I know y is equal to 5x, or 5 times x plus 19, I can put that negative 4 in for that x. So remember, that's multiplication, so that's 5 times negative 4 plus 19. So 5 times negative 4 is negative 20, plus 19 is negative 1, so y is negative 1. So my ordered pair is negative 4, negative 1. Now, if you want to know whether that's correct or not, you can put negative 4 in for the x in both equations, and negative 1 in for the y in both equations, and make sure it makes a true statement in both. So I can show you that. Let me show you for the second one. Since the second one was negative 3x minus 8y equals 20, if I replace x with negative 4 and y with negative 1, I want to know, is that correct? Well, negative 3 times negative 4 is 12. Negative 8 times negative 1 is positive 8. And 12 plus 8 is 20. So it works for that one. And then you can put it into this one. Y equals 5x plus 19. Replace y with negative 1. Replace x with negative 4. And see if that works. Well, 5 times negative 4 is negative 20. Negative 20 plus, whoops, that's a 19, not a 9. Negative 20 plus 19 is negative 1. So, yep, it worked on that one as well. All right, let's look at number 15. Number 15 is just one step harder than number 14 because none of my variables are isolated yet. I always look for the one that's easiest. Look for a variable that has a coefficient of 1. Well, this one has a coefficient of negative 3. This has a coefficient of 4. This has a coefficient of negative 1, but this has a coefficient of 1. This is what I want to solve for. So to get y by itself, I have to get rid of this negative x. To get rid of a negative x, I can add x to both sides. So y is equal to positive x plus 3. That negative x went to the other side and it had to become positive. So now I'm going to do exactly like I did over here. In my other equation, I'm going to replace the y with x plus 3. Since y and x plus 3 are equivalent, I'm replacing y with the x plus 3. So I'm going to write this equation exactly like it is, except instead of the y, I'm going to put parentheses. And in place of the parentheses, I'm going to put what I'm replacing y with, which is x plus 3. Now I have an equation with just x. So the first thing I'm going to do is get rid of the parentheses by distributing that 4. So I have negative 3x here. 4 times x is positive 4x. 4 times 3 is positive 12. I can combine these two because they're like terms, so they both have an x. Negative 3 plus 4 is 1, so that's just x plus 12. If you want to put 1x, that's fine. Equals 4. And I'm undoing addition using subtraction. 4 minus 12 is negative 8. So remember, the answer is going to be a point. I just found the x part of it. Now I need to find the y part of it. I'm going to go up here. Remember when I solved for y up here? If y is equal to x plus 3, all I have to do is replace that x with negative 8. So y is equal to negative 8 plus 3. What's negative 8 plus 3? Negative 5. So my y is negative 5. So, whoops, there's my answer. Negative 8, negative 5. Number 14 was negative 4, negative 1. Again, you can check that. You can go back up to each one of these equations, replacing the x's with negative 8, replacing the y's with negative 5, and make sure that satisfies both equations. Be careful when you replace x with negative 8. That negative that's already there changes the sign to positive 8. So you would have negative x, so you'd have negative 8. Well, that makes that a positive. So that would be positive 8 plus your y, which is negative 5, equals 3. Yep, works on that one, doesn't it? And then you could check the first one.